Chapter 11.3 Hyperbolas. Out of all the shapes, mechanics sections, this is the one that confuses people the most, mainly because they're harder to deal with because of the algebra and to draw. A hyperbola is a symmetrical open curve formed by the intersection of a double circular cone cut by a plane through both halves. On the right here, we have an example of a parabola and an ellipse. But that do not matter, because what really matters are hyperbolas. So on the bottom, we have a diagram with parts labeled. For example, the yellow dotted lines are the directrix, and we have the vertices labeled, the foci, the two asymptotes, and the axis of symmetry, which should be the transverse axis, and the vertical line in the middle is the conjugate axis. And now to label a hyperbola. This is the conjugate axis. Of course, this line segment right here. This thing's. And that's also known as B. The transverse axis, on the other hand, is known as A. Some line segment right there. This is known as A, and this is B. And the foci are the 2 points right here. This part of the asymptote is known as C. The vertexes are right here, both of them. The center, of course, is in the center. And yeah. And now for the standard equations of a hyperbola. For a horizontal hyperbola, which opens left or right, the standard equation would be x minus h squared over a squared minus y minus k squared over b equals 1. Remember, this is the transverse axis and this is the conjugate axis. Now for the other type of hyperbola, which is the vertical hyperbola, and opens up to down, or vice versa. The standard equation for that would be y minus k squared over a squared. That doesn't change. Minus x minus h squared over b squared equals 1. Notice how the a and the b never change, but the numerators do for both types of standard equations. A way to not get confused when dealing with both types of standard equations is to draw like a little picture beside them to remember. Like for the horizontal hyperbola, I always draw lines like that, and it would be like the graph would come out looking like that, but I only draw this part. And for the vertical, you could draw, and that's just how I remember it. Another thing that we want to know, that we need to know, is that the center is always h, k. For both of these standard equations, the center is at h, k, and in order to find the foci, which is c units away from the center along the transverse axis, there's certain equations to find that. For example, there's the Pythagorean theorem, which is a squared plus b squared equals c squared. And there's also another form of it, which is c equals square root of a squared plus b squared. For example 1, we need to use the information provided to write the standard form equation of each hyperbola. So we could count right here easily that this is 1, 2, 3 units. So a equals 3. This is the transverse axis, which is y, that's a. For the conjugate axis, which is b, it's 1, 2 units. So b equals 2. The center is at 0, 0. And we could tell already just by looking at it that this is a vertical hyperbola, which means that y will come first. And since our center is at 0, 0, we don't really need to take. It wouldn't make sense to be like y minus 0, because that just don't make no sense. So might as well take that off. That looks dumb. Over a squared, which would be 9, minus x again is 0, so might as well just put 0, over b squared, which would be 4, equals 1. Oh, I forgot, yeah. Squared. Now that is the equation for this. Adding on to example 1, the vertices are at 0, 3 and 0, negative 3. But that was not going to be included in the graph. The endpoints of the conjugate axis are at 0, 2, no, I wrote that wrong. Yeah. 2, 0 and negative 2, 0. And the distance, which is the b of the conjugate axis, is this number, which is distance, so we're just going to use 2 because there's no negative distance. And now to find the foci, we could put it into either equation, and I'm going to just use the Pythagorean theorem, which is c squared equals a squared plus b squared. And let me just plug those numbers in. C squared will be 9 plus 4. C squared equals 13. And then to find the foci, it would be u square root. So the foci would be, and then this is just a number that would go into. So now that we found the one of the coordinates of the foci, we just plug that into the graph, and the foci would be found in between here. So now that would be negative square root of 13, 0, and 13 square root of 13, 0. So those are the foci. You're presented with just a couple informations, and then teachers expect you to do the rest. Well, luckily, you've learned, so hopefully. So if we're given the information that the vertex is at 5, 0, and at negative 5, 0, we could just put that here, and then like, to not get confused, the endpoints of the conjugate axis are right here. So we could already draw our square box, or whatever that is. And now we have to write an equation for it. Let me just draw these lines. This is what our hyperbola looks like, and it looks wide because of these coordinates. So we can easily see that this is a what's it called? A horizontal hyperbola. So this means that the x would be first. X minus the center again is at 0, 0. So I might as well just leave it at x over a, which is the 2, 3, 4, 5 transverse axis, which is at 5 squared, minus again the center is at b, so just put a y over the 1, 2, 3, 4 b, which is 4 units squared, equals 1. And now you just square these, I guess. Just x over 25 minus y over 16 equals 1. And don't forget to square these top. Yeah, that's the answer. So now for this practice problem, if you've been paying attention, this would be easy. Hopefully you did pay attention. So what I want you to do is to use this information to write a standard form equation of each hyperbola. So the center will be at 3, -5, and this time I'm going to use the transverse axis. The transverse axis is horizontal. And the central rectangle is 4 units wide and 12 units tall. Now you just gotta find out the equation. So if the center is at 3, -5, and the center rectangle has a width of 4 units and is 12 units tall, the center would be right center of the box. So in order to find b, this whole length is 4 units, and b is just a half of it. So b equals 2. And then to find the a, which is on the transverse axis, which we know that is 12 units, we only need a half of it, so a equals 6. And now with this information we can write our equation. We know that's a vertical. It's a vertical. What's it called? No. It's it's a vertical equation. So y would come first. Y minus y minus 3 over 36 minus x plus 5, because this -5 turns positive, over RB, which would be 16, equals 1, and of course it has to be squared. this is the answer. And now to finish off, here's the last practice question. So you need to find the center A and B of this equation, this graph I mean. So the answer for the last practice question is the center is at 0, 2, A is 3, B is 4. It's a vertical hyperbola. And the equation is y minus 2 squared over 9 minus x squared over 16 equals 1. Congratulations! You can now test on the hyperbola.